Here's a radical equation. The first thing to do is isolate this radical, so we're going to need to add x to both sides. So the square root of 5x plus 3 is on the left-hand side, and then x plus 2 is on the right-hand side. And the reason for doing this is now we can eliminate the radical by squaring both sides. But on the left-hand side, I just want it to be a radical that gets squared. They're going to cancel each other out, leaving just 5x plus 3. On the right-hand side, this binomial needs to be squared, so it's going to be square the first term, square the second term, multiply the two terms, and double it. Or you could use the FOIL method. Now that it's quadratic, I'll probably end up using the quadratic formula, which means that everything needs to be moved to one side. So subtract 5x from both sides and subtract 3 from both sides. So we've got 0 equals x squared minus x and plus 1. And then use the quadratic formula. X is equal to negative b plus or minus the square root of that negative 1 squared will be positive 1 minus 4 times the a times c. And then it's all divided by 2 times a. So this is going to be 1 plus or minus, and then in here there's a 1 minus 4, so that's negative 3. So we've got the square root of a negative, which is a complex number, which means as far as real numbers, we've got no solution. If we were going to deal with complex numbers or imaginary numbers, then we'd only have one more step where we say, well, the square root of a negative 1 is an I, and then we would have the complex number solutions. Now I want to graph this and verify that there are no real number solutions. So graph the square root of 5x plus 3 minus an x. So always go back to the original equation and graph that. And then when is that equal to 2? And there should be no place where the two intersect. Oh my, it looks like they do intersect right there. Let's just double check. Zoom in to this area where it looks like they're intersecting. Wow, that's a close one, but no, they do not intersect.